And so the bad news is we have to be able to write the names and formulas for molecular compounds. Good news, it's easier. In fact, it's so easy, I'm going to have to fight you trying to use it to do the stuff we've spent a week doing. You're going to try to unlearn everything I just taught you. Don't. Okay? So all we're going to do is write the names and formulas for molecular compounds. Okay, remember they're made of just nonmetals. If you look at all the homework we have done for the past week, the first element was always a metal, because everything was ionic. Okay? Ionic compounds had formula units. We actually get molecules where specific atoms are joined and stay together the whole time. But why do we need a whole new set of rules? Well, it has to do with this. In order to figure out iron 3 oxide had those 2 irons and 3 oxygens, I had to use the charges, right? Molecular compounds, that's not going to work, because everything in a molecular compound is a nonmetal. Nonmetals get negative charges. A negative plus a negative, when is that going to equal 0? Never going to equal 0. Molecular compounds are never going to add up to 0, right? Because everything's a negative piece. So I can't use charges to figure out how many. I mean, iron 3 oxide, put 3 plus 2 minus, do the crisscross, I know how many of each. I can easily figure it out. Molecular compound, there is no way to figure it out. Would it be fair for me to say, I want you to draw the formula of a compound that's got carbon and hydrogen in it? Think about how many compounds you drew last chapter that had just carbon and hydrogen. There's a whole bunch of ways to put it together, wasn't there? So I can't just say carbon, hydrogen. I got to be specific. So if I can't use charges to figure out how many, the name has to tell me how many. This is easier. Okay? It's easier because the name is literally going to be something like 4 iodines and 9 oxygens. Would it be easy to figure out the formula of something if the name was 4 iodines and 9 oxygens? No, it's almost that easy. Okay. Because we can't use charges, the molecular compounds, the name tells you the charge. I already said we can't use charges, so we can't figure out how many, so the name has to tell me. So the name will be 4 iodines, 9 oxygens. That'll be pretty easy to translate into a formula. And the only difficulty is they don't write 4 and 9. They use the prefixes that mean 4 and 9. Now, you've learned prefixes that mean numbers in your math class before. I forget whether these are the Greek or the Roman. I forget whether they're cardinal or ordinal. Okay. All I know is it's the ones you put before agon, for the most part. It's the one about the shapes. So most of these will be familiar. There'll be 2 or 3 that you haven't heard before or heard and forgotten. Okay. So we need to know the prefixes, and we need you to know the prefixes up to 10. You should not be surprised by what the list is. This list I won't provide for you. You're going to have to memorize it, but you should know most of them anyway. You won't be surprised by this list. Here's the prefixes you need to know. The prefix that means 1 is mono. Is this the first time you've ever heard the prefix mono mean 1? Well, mono always means 1. Okay? And because there's other ones where it's uni, those types of things. Prefix for 2 is usually the same just about everywhere. What prefix means 2? Di. Di means 2. Di means 2. 3, everybody knows. Go ahead, try. Tell me what it is, try. Oh, it's try. I don't have to try, I can do it. No surprise there, right? 4, I've already taught you. Tetra. Tetrahedral, 4-sided, right? Tetris, 4 blocks. Every shape in Tetris is 4 blocks. That's why it's called Tetris. There's a big building in Washington with 5 sides. It's a pentagon. Or, for our pagan friends, pentagons. I don't know, what's it? Pentagram. Okay, 6. Name this shape. It's a hexagon, right? 6 is hexa. Right? 7, most people forget 7. Hepta. Almost everybody knows 8, though. 8-armed sea creature. Octopus. Octa means 8. Octagon, the squared circle. 9. Nana. And 10. 10 will be familiar too. How long is 10 years? It's not any for 10 years. Decade, they call it a decade because deca means 10. Okay, mostly familiar prefixes, right? This is not a hugely different list. Mono, di, and tri, familiar. I taught you tetra. Penta, maybe. Hexa, most of you. Hepta, almost nobody. Octa, everybody. Nana, almost nobody. And deca, just about everybody. Okay, so what do we do with these prefixes? Okay, to write the name of a molecular compound, you need to write 2 words. Game of charades. First word sounds like, no, that's charades. So it's going to be 2 words, just like most of our other names. Think about all the names you wrote. Almost all of them are 2 words except for the ones that had hydrogen sulfate in them. First word. Starts with a prefix, because prefixes get written before. Then you write the whole first name. You don't change the ending. Then, second word. Another prefix for how many of the second element you have. The name of the second element, but you change the ending to IDE so everybody knows you're done talking about that chemical. So we're going to translate 4 iodines, 9 oxygens. That kind of stuff. Instead of 4 and 9, we'll use prefixes. Right? There are a couple of, I'm going to put I to the second one. A couple of minor exceptions. If there's only one of the first element, we don't write mono. We just write the name of the element. So no name should ever start with the prefix mono. So you never put mono on the first one, but if there's only one of the second, you put mono. That's because if you alphabetize these, you'd have a whole section that was just mono. And that wouldn't do you much good. And the second one is, because it sounds bad if you do it wrong, is got to watch out for double vowels. Like you don't want AO or OO. Those you want to change and get rid of the first one. So you'll get rid of the first one of each one of those. And I got IO, OI, AI, and actually II are all okay. So to say 3 iodines, you would say triiodine. Triiodine, both I's. And that O is going to show up in oxide most often, because that's the only non-metal starts with an O. But that's all the rules. Sound easier? Won't believe how easy it is until you try it. So the only ones you got to worry about are the AO and the OO. So name this compound. N2O. So I want to say 2 nitrogens and 1 oxygen. 2. I had to say 2. Di. 2 nitrogens. Dinitrogen.
Do you put like the dinitrogen?
Yeah, it's one word. It's one word. It's a prefix, so it's attached. Okay, and you're going to want to write monoxide. But as soon as you do that, you will realize that if you try to read that out loud, you're not going to say monoxide. You're going to say monoxide. That's why we don't have the OO double vowel. Monoxide. That's what we meant by the no OO double vowel. You're not going to say monoxide. Okay? As opposed to 1 nitrogen and 2 oxygens. Now the prefix that means 1 is mono, but I don't ever start it with mono. 2 oxygens, dioxide. So dinitrogen monoxide, 2 nitrogens, 1 oxygen. Nitrogen dioxide, nitrogen and 2 oxygens. Pretty simple, isn't it? The only way it gets worse is you got to try to pronounce these things. So they're easy to write, they're a pain to pronounce. So Cl2O7. So to say 2 chlorines, 2 is di. Chlorine, I leave the first word alone. 7 oxygens, 7 was hepta. But I don't want to do heptaoxide, I just want to get rid of that A. Because I don't want to leave the A because I want to talk about oxygen. The key is that it's oxygen, so I need to keep the O for oxygen and change the N to IDE. So dichlorine heptoxide. Everybody see BR4? CPR4? That would be carbon. Don't have to say monocarbon because if there's only one, we leave the mono off. How do I say 4? That was tetrabromide. I changed the ending on the second one, so we know we're done. Okay, so let's not do the systematic name. Give me the common name of this chemical. Everybody knows that's carbon dioxide, right? Notice it follows the rules. Carbon to oxygen. So you knew how to name those compounds already. You're using carbon dioxide all the time. Versus CO, which is carbon monoxide. And what about BaCl2? Write the name of BaCl2. And once you've done that, everybody's going to agree with me that the name is barium chloride. It's barium chloride. It's just chloride. Because you guys skipped a step. You said, we're going to use the molecular rules, but first you should decide which set of rules do I follow? Because barium is a metal. It's not a nonmetal. This starts with a metal. It's ionic. Ionic doesn't get prefixes. Ionic, if I tell you barium chloride, you don't need the prefixes. Because barium's in the 2 plus column, chloride's in the 1 minus column, they don't add up to 0, you're going to get BaCl2. I don't need prefixes for the ionic ones. So your first decision is not, what's the name of this? Your first decision is, which set of rules should I use to name this? That make sense? So that's what this blue diagram's about. So if you got the blue paper, I'm going to fill in a couple more boxes for you. So grab that blue paper. We want to start off on the side that says name 1 and name 2. The one with the dotted lines. And when we did this the other day, we filled in this because we were only naming ionic compounds. But what we really have to decide is which kind of compound is it first. So that's what those first 2 decisions are. Okay? So apparently we've got to learn how to do acids too. Right? So if you notice, it's a diagram where there's yes, no answers. So, and it comes out of name 2. So the second word in the name. If the second word in the name is acid, it's an acid. If the second name in the word is not acid, it is not an acid. So they give you a big clue that it's an acid because they put acid in the name. Okay? So if it says acid, it's an acid and you go over there and do that. We're not ready for that yet. But if the answer is no, then you're at this decision and you have to decide between going down to molecular and over to ionic. And all you have to look is, does name 2 have a prefix? If the second word has a prefix, that means you're following the molecular rules. So that means it's molecular. If the second word doesn't have a prefix, that means they expect you to figure out how many, which means it's ionic. So if it doesn't tell you how many, it expects you to find it out. So that lack of a prefix on the second word, okay, which is what barium chloride was missing, was that prefix, because it was ionic, not molecular. Okay. And then if you go down, it's not a decision. Notice this doesn't branch. All you do is whatever prefix is first goes after the first nonmetal, what prefix is second goes after the second nonmetal. That's how you write a formula out of this. So if it says 4 iodines and 9 oxygens, you write I4O9. That's pretty easy. Okay, but I didn't give you the name last time, I gave you the formula. So flip the paper over, and you'll see your first 2 decisions are about, do I go to ionic or do I go to acids? And this time, it comes out of the first element. If the first element is hydrogen, it's an acid. That's what the yes means. If it is hydrogen, yes, then does this thing start with an H? If it's yes, we're going to name it like an acid. If the answer is no, we've got to move on and decide between molecular and ionic. To decide between there, you say, is that a metal? Because if it's a metal, you go to the ionic side. If it's not H and it's not a metal, it's going to be a nonmetal. And we go down to the bottom and use those prefixes. So we've got to remember to make that decision first. So on tonight's homework, in some of them, I have them mixed together. So you've got to decide which way to name it first. Because you want to put prefixes on everything now, don't you? You feel that urge. You're only allowed to put prefixes on specific ones. Tomorrow's quiz, do not use a prefix tomorrow. If you use a prefix tomorrow, it will be wrong, right? Because the day before the quiz is never on the quiz. So none of these molecular ones will be on the quiz tomorrow. Okay? So all I've got left is write some formulas. Write the formula for diphosphorus pentoxide. They are harder to say than they are to write. Diphosphorus pentoxide. Well, di, 2, phosphorus, right? So that means P2, pent, 5, oxide, O. It is literally, the name is the formula. So much easier. Tetraiodine nonoxide. I've been talking about this one all period. Tetra is 4, iodine. Non-oxide, does that mean it's not an oxide? No, non is the prefix for 9. Nana. Doesn't mean it's not an oxide, it means it has 9 oxygens. That's why I put it there, is because some people are going to think that that means not an oxide. No. If you saw, before today, if you see non-oxide, you would say it's not an oxide, right? That would be your definition of it. But actually it means 9 oxygens. Sulfur hexafluoride. Well, sulfur's S. How many S's? Well, it didn't say, so it's 1. Hexafluoride. 6 fluorines. Fluorine's F. Awful. Here's one that's going to cause slight confusion. I want to clear that up before we move on. Nitrogen trioxide. Say, well, how could that cause confusion? Nitrogen's N, trioxide, O3. What's the problem? Because there's going to be somebody who asked me about this eventually. Said, excuse me, Mr. Green, on this piece of paper it says NO3 is nitrate. Which one is it? And the answer is, it depends on that little piece right there. Because this is polyatomic ions, things with charges. That nitrate would be next to something positive. It had to steal an electron from somebody. It's going to be part of an ionic compound. NO3 doesn't have a charge. So that means it's by itself. NO3 is actually a gas. Does that make sense? So if it has a charge, it's an ion. If it doesn't have a charge, it's not an ion. Okay? And that's why one of the answers on the last review sheet was sometimes true. That when you make covalent bonds, you make molecules. It's only sometimes true because you can make molecules like NO3, or you can make polyatomic ions like NO3 minus. Okay? That's why it was a sometimes true. Okay? Carbon tetrahydride. The reason I gave you this is because this chemical has a common name. Its common name is methane. What does methane tell you about it? It doesn't tell you anything, does it? But this name, carbon tetrahydride, carbon, tetra, 4, hydride, hydrogen. See why carbon tetrahydride is more information than methane. See why we like the systematic names better than the common names. How about natural gas? Because that's what methane is. Stuff that comes out of the pipe. Okay, phosphorus trifluoride. Go ahead and finish writing that one down. Everybody get that? Phosphorus, 3 fluorines. Phosphorus, 3 fluorines. Aluminum chloride. That's the formula for aluminum chloride. Okay, if you've been paying close attention, you will have written AlCl3. Mr. Green, it does not say trichloride. Nah, it says chloride. Does chloride have a prefix? Does chloride have a prefix? No. Does name 2 have a prefix? No. If it doesn't tell you how many, they expect you to figure out how many. Aluminum's a metal. Aluminum's 3 plus. Cl's 1 minus. I can make this equal 0. See why I said I had to teach you the hard one first? Because you'd want to do this one all the time. Right? So we did the hard one, so that's why it's got to be AlCl3. Do my crisscross. So your first decision is not, how do I name this? Your first decision is, which of the 2 sets of rules do I follow? Do I use prefixes or not prefixes? Okay? So that's why I structured tonight's assignment on the front side. So your first decision is it ionic or molecular? And then write the name of the formula. Now, I know that you can do this by just labeling them ionic and molecular all the way down and then working your way across. But that's not how you're going to do it when you're answering other questions. So I would suggest you make this decision, then name it. This decision, then name it. Get used to making that decision about ionic or molecular before you write a name. Otherwise, you're liable to follow the wrong sets of rules at the wrong time. That make sense?